I'm Lohit, and today I'm going to explain you guys about the project which I have made recently. This is called Smart Water Monitoring using IoT. So, going on, why did I make this project? I made this project because I thought that I could make a system which could tell us the amount of water which we are using. Mainly because of the challenges which are facing presently. The few of the challenges which are presently in our country is that of water. There is a lack of water. There is a lot of water which is being wasted. There's mismanagement of water. So how can these challenges be tackled? So what I saw is that an IoT based water monitoring system can be a solution to tackle this problem. So moving on, let me show you what I did. So this is the basic circuit diagram of the project which I have made. As you can see, I have used an Arduino board as an Atmega 328 microcontroller. Also, I have used an ESP8266 module. Also, a water flow sensor. So what happens is that when water is pumped to the water flow sensor, then it gives the flow rate. And also this data is pumped into the cloud by using this ESP8266 Wi-Fi module. This water flow sensor works on the principle of Hall effect. So this is the basic outline of the project. As you can see, this is the ThinkSpeak is nothing but an data analytics platform which helps us analyze our data more visually and graphically. So one more concept which I have used in a project is that of an interrupt. An interrupt is nothing but an interruption in the code. So when we paste through our main code, and suddenly if we give a statement called attach interrupt, then it jumps from that point into another piece of code which is called an ISR, which is a short form for interrupt service routine, and it executes this code first and then moves back to the main code. So this is the basic concept of an interrupt. Also, this piece which I put here is the calibration factor of our water flow sensor which we use. As given by the manufacturer, uh, the water flow sensor produces 4.5 pulse per second for every 1 liter per minute of water which we pump in. So as a conversion factor, we can get the flow rate as equal to the pulse count into 1000 divided by 4.5 into the time. So as you can see, this is the time difference, which I generally kept it as 1 second. So for every 1 second, we get a pulse count, and in turn we get a flow rate, and this flow rate is appended into another variable called total flow, and this total flow keeps on iterating for every iteration, and finally we get the count of the total amount of water which is being flown inside the water flow sensor. So this is my entire setup. As you can see, I have an Hall effect sensor or a water flow sensor, an ESP8266 module, and an Arduino board. So I have connected this to my computer, and as you can see, this is the code which I have burnt inside my Arduino Uno, and also I have already uploaded it, so you can see the serial monitor how the readings have been taken. Now what I'm doing is that I'm taking some water and I'm pouring it into the Hall effect sensor. So now I put it. Okay. Now let's see how the readings have changed over the past. Yep. Now you can see that the total ml has changed to this value, and also you can see the same thing on my ThinkSpeak account. So I have made only two fields here. One is a milliliter per minute, and the other one is for the total flow, which is also in millimeter per second. You can see this is milliliter per second, and this is also in milliliter per second. So this is how my ThinkSpeak account is updating for the amount of flow which we are giving inside the water flow sensor.